Okay, 6.5 day 2, we're just continuing our log properties with a little bit of radicals. Okay, so I'm going to rewrite the logarithm using the power property just like the last one. So for the log base 6 of x to the 5th, I'm going to bring the 5 down. Okay, and we're just practicing the skill. There will be times at which that's useful. So we're just practicing it for that. Okay, now if I look at B, it says the log base 4 of the square root of m. I need to use the power property, but I don't have an exponent, so I need to rewrite this with an exponent. Okay, now if I'm doing a square root, what is the exponent? It's 1/2. It is 1/2, because if I rewrote this, it would be the second root of m raised to the first power. So the square root of m is m to the 1/2. Now I can do the power property and bring the 1/2 down. Okay, and then that's what the power property would look like with a radical. And you're going to show both steps. Okay, let's look at C and try the same idea. I want to use the power property. It's a 7th root. It does not have an exponent currently, so I need to rewrite it with an exponent. If I'm doing a 5th root, the exponent is 1/5. Okay, now that I rewrote it as 7 to the 1/5, I can bring down the 1/5. Okay, now the log of the 3rd root of n to the 2nd. Okay, same, let's rewrite it with an exponent. Okay, now it already has an exponent. The exponent is a 2. But I'm 3rd rooting it and I'm raising it to a 2. So I'm raising it to a 2, but I'm 3rd rooting it, so the denominator is a 3. So this is saying the 3rd root of n squared. Okay, now I can do the power property. Bring down the 2/3 of the log of n. Okay, now let's use this information to try to expand some different logarithms. Okay, so just like yesterday, we're using the product and the quotient one. So first thing, this is the log base 3 of 5 times the square root of x. So I'm going to break it up into each individual factor. So first I have the log base 3 of 5. And then since the arguments are being multiplied, I'm going to add the log base 3 of the square root of x. Okay, now when I expand, I cannot leave exponents. And I don't see an exponent, but I do see a radical, which means I do have an exponent. It's just disguised as a square root sign. So since this is the square root of x, I make it a 1/2. Okay, now I can see the exponents there. So I'm going to bring it down, because when it's fully expanded, there should not be an exponent there. Okay, now I'm fully expanded. I separated all my factors in the argument, and I've brought down all my exponents. Let's look at the next one. Okay, so it's the ln of m to the 3rd, ln of m to the 3rd. I'm multiplying by the 5th root of n, so I'm going to add the natural log of the 5th root of n. Okay, I can bring the 3 down on the natural log. Okay, now there's no exponent on the 5th root of n, but I know that if there is a radical, there is an exponent. The exponent, if I'm 5th rooting, is 1/5. Okay, so let me bring down the 1/5, the natural log of n. Okay, now I'm fully expanded, broke up all factors, brought down all exponents. Okay, now we're going to get a couple messier ones, and then we'll start condensing. Okay, log base 4. Okay, what's at the top? The 3rd root of x is at the top. Y squared is at the bottom, so I'm going to subtract the log base 4 of y squared. Okay, I see a radical. If there's a radical, there's an exponent. If it is a 3rd root, the exponent is 1/3. Okay, I can bring the 2 down over here now if I would like. So that one's good. Now let me bring the 1/3 down on the first log. Okay, now this is fully expanded, broke up all the factors, brought down all the exponents. Okay, let's look at H. Log base 8. Okay, let me start with the first thing. I see an x to the 5th. What else is on the top? The log base 8 of y. And then on the bottom, subtracting the log base 8 of the 4th root of n. Okay, 5 times log base 8 of x looks good. The log base 8 of y looks fine anyways. Since there is a radical on the n, this represents an exponent. The exponent is, if I'm fourth rooting, the exponent is 1/4. Okay, so let me bring down all that stuff. And then bring down my last exponent. Okay, now I'm fully expanded. Okay, now we're going to condense them just like we did before, but adding in the information we now know about radicals. Okay, remember, if you're condensing, we want our final answer to be the log of something, and that's it, which means this 5 cannot be here. So let me put the 5 back in the exponent spot. Okay, so the same with the next one, that 1/2 should not be there. So let me put it back in the exponent spot. Okay, now I'm going to add a step that you might not include. You might skip to the answer, and I'm okay with that. Okay, now if I do the log base 2 of y to the 1/2, I am square rooting y. So if it's a fractional exponent, we want to rewrite it as a square root because it's a more simplified answer. Okay, now I'm going to write it as a single log. So it's log base 2. Since I'm adding, I'm multiplying them, so it's x to the 5th times the square root of y. Okay, let's try the next one. Okay, the 1/3, let's move it up. Nope, this one's okay. Okay, let's rewrite 7 to the 1/3 because the fractional exponent represents a radical. This is a third root of 7. Okay, now as a single log, they're both log base 6. Since they're being subtracted, it's going to be a fraction. The third root of 7 is at the top because it's positive. The 11 is at the bottom because it has a minus. And that's my simplified answer. Okay, let's try 2 more, and then we'll show you one other use for it. Okay, what do we see? Oh, no, there's some exponents I gotta move. Okay, that 2 can't be there, so let's move it up. What else? Yep, the 1/2, move the 1/2. Okay, I think I'm gonna rewrite the square root now, although you could do it later. You know what, that's a number, let's just multiply it. 3 squared is 9, let's make it a 9. Minus log base 4 of, 49 to the 1/2 is the square root of 49. Okay, let's make this a single log. They're all log base 4s. Okay, what do I have at the top? I have a 2. I'm adding log base 4 of 9, so I'm multiplying. And then I am subtracting log base 4 of the square root of 49, so the square root of 49 goes on the bottom. Can we do better? We can do better. What do I get at the top? Oh, I'm going to put it next to it. At the top, 2 times 9, I have 18. At the bottom, the square root of 49 is 7. Does that simplify 18 divided by 7? No, so we'll leave it like this. Log base 4 of 18 over 7. Still a good answer. Okay, let's condense this last one. Okay, do I see? Yep, the 1/3. So the first one look okay, but that 1/3 does not. Log base 5 of 2. I'm going to move the 1/3 up. Okay, I'm going to rewrite that as a radical now, although I could also do it after I write my fraction. Since it's 10 to the 1/3, that's the third root of 10. Okay, I'm ready to make it a single log. So this is the log base 5. There is definitely a fraction because I see minus signs. Okay, log base 5 of 7. 7 is at the top because it's positive. I'm minusing the log base 5 of 2, so the 2 is at the bottom. I am minusing the log base 5 of the third root of 10, so the third root of 10 is also at the bottom. Okay, do I know the third root of 10? No. Can I divide 7 and 2? No, so this is a good answer. Okay, one last type of problem. Okay, so for example 6, it says use log base 2 of 5 is about 2.3 and log base 2 of 7 is about 2.8 to evaluate the logarithms, and they want you to use log properties. Okay, sometimes this happens to be a known base. Sometimes they give you a letter here. So you can't do it without using the properties. Okay, so that since they only gave me the log of 5 and the log of 7, I need to rewrite this in terms of log 5 and log 7. Okay, I see a 7 here, I see a 5 here. So I'm going to expand it using the log properties. So this is log base 2 of 7. I'm going to subtract the log base 2 of 5 based on the log properties. Okay, this is good. Okay, now they told me what the log base 2 of 7 is. They told me it's 2.8. So now I'm going to write this as 2.8 minus the log base 2 of 5 they gave to me is about 2.3. If I do 2.8 minus 2.3, I get about 0.5. So according to their approximations of my log properties, the log base 2 of 7 over 5 is about 0.5. Okay, let's look at B. Okay, they want me to do log base 2 of 35. But I only know 5 and 7. So I need to rewrite 35 in terms of 5 and 7. How can you use 5 and 7 to get 35? Yes, I do 5 times 7. 5 times 7 is 35. This is better because now I can use my log properties. I cannot use them now, I have to separate them first. So this is going to be the log base 2 of 5, and since they're being multiplied, I add log base 2 of 7. Okay, now I can substitute. The log base 2 of 5 is 2.3 because they gave it to me. The log base 2 of 7 is 2.8 according to what they gave me. Okay, and then I'm going to add them up and I get 5.1, I think. Okay, so according to what they gave me, this is my approximate answer. Okay. Okay, now for the log base 2 of 49, I need to rewrite 49 in terms of 5 or 7. It's not 5 times 7. What is it? It's 7 times 7. Okay, so actually there's two ways to do it. I'll show you both ways. One way would be to say this is 7 times 7. So when I use the log property, that would be the log base 2 of 7 plus the log base 2 of 7. What is log base 2 of 7? It's 2.8 according to this information. So 2.8 plus 2.8 would be 5.6. So that's one way you could do it. The other way you could do it is to say this is the log base 2 of 7 to the second power. And it's not okay to have the 2 there. By the power rule, I would bring down the 2. But then the log base 2 of 7 is supposedly 2.8. So if I do 2 times 2.8, I also get 5.6. So that's the second method for doing it. Okay, let's look at the last one. It's log base 2 of the square root of 5. I can't just square root the answer because I would be square rooting the whole thing. I'm only trying to square root the 5. So I need to rewrite this. Okay, I see the 5. Okay. I'm going to put an exponent on the 5 to represent square root. So this is going to be 5 to the 1/2. I'm going to use the power rule. Let me bring it down. Okay, now this is the log base 2 of 5, which is equal to 2.3. So I'm going to bring down the 1/2. And where it says log base 2 of 5, I can put in 2.3. Okay, so the 1/2 of 2.3 is, I'm going to use my calculator. I got 1.15. Okay, and when you plug in, you have to get it all the way till it says log base 2 of 5 or log base 2 of 7. That 1/2 could not stay there. The square root cannot stay there.